Hello everyone, welcome. Today I will explain about Web3 node engine service, which by developed Huawei. This is Huawei cloud service that using on the blockchain and Web3 technologies. Firstly, I am Hakan Aktaş and I'm working on Huawei as a cloud engineer for about 1 year. I can say my main domain is related AI, artificial intelligence, and Web3 and blockchain technologies. Today, I will try to explain how we can use node engine service on blockchain and decentralized application. I can start actually. Today's sessions, as I said, I will be introducing blockchain and Web3, two important technologies for the future of the internet. And then we will look at what blockchain is and how it is work. We will try to understand the main idea, main concept behind of. Actually, the technology allows secure, unchangeable records because, you know, the centralized application, the data stores in the one data center. After understanding how it's works, we will explore some real world applications of blockchain. Then we will discuss Web3, any version of the internet built on the blockchain technologies. For a short description, Web3 focuses on decentralizations and gives users more control. We will also cover smart contracts, the most important usage of the blockchain. The smart contracts actually, which allows secure and automatic agreements without any centralized user or someone. Then I will explain the Web3 node engine service, NES, a tool for building and managing blockchain-based application. We will go over its main features, how to use it step by step, and see examples of real use cases. Finally, I will show you a short demo showing how to use Web3 node engine service in action. By the end of the today, you will have a clear overview about the usage of the node engine service. So let's start. Let's take a look at the blockchain and Web3 and understand why they are so important today. Maybe maybe you are familiar with these technologies. Blockchain actually is a special type of database. We can say that easily. It stores data in a way that makes it secure and unchangeable. And actually, the most general usage is one database, and the database controlled by one user, one big company, and we should trust them. If they are changing the database, we cannot anything. But blockchain is decentralized, which means no single person or groups controls it. This makes blockchain very reliable, especially for sensitive information. For example, in the telecommunication. The information of the telecommunication or financial data is very important and personalized data. So we actually, in the best practice, we don't want to control. We don't want to give the controls, all controls of the data, because data is very important. The blockchain allows us to manage the data, a lot of databases. So anyone cannot change and cannot manipulate the data. And Web3, actually, on the other hand, is often called the new generation of the internet. Maybe you hear that Web 1, Web 0, Web 1, Web 3. Unlike today's web, which is controlled by a few big companies, as I said before, Web 3 is decentralized and built on the blockchain. You can imagine that there is a chain which consists of blocks, and we can develop an application, any kind of application. It can be a web application or a e-commerce, something like that. Actually, this means users have a control over their own data and online identities. Web3 allows for new applications that are more secure and private, and it offers new ways to create and share value on the internet. We don't need to anyone. We can join the blockchain and we can manage our data. Actually, to summarize, in short, blockchain and Web3 together promise the future internet that is more secure, open, and user-friendly. So we can pass by exploring how blockchain works in details. Blockchain actually operates on the centralized network of the computers. Yes, we can imagine the nodes as a computer, like data centers. We can call it nodes that work together to verify and store data. The data is same, all of the nodes. For example, we need to send some information. We can call it transactions. When new data or a transaction is added on the blockchain, it first needs to be validated by these nodes. Actually, we cannot send any information without verification. There is a lot of there may a lot of nodes on the blockchain, and all of them should be verify and accept this information is okay, and we can accept it. As I said, each node actually checks the data to ensure it's correct, and once verified, the data is added as a new block on the blockchain. If every node can say it is okay, the information, the transactions added the blockchain at the end of the blockchain actually, and no one can change it. So we can say that it's very secure. The security is very important. Blockchain works linking data into blocks. Each block is connected to one actually before it, forming a chain. We can think it a chain. This structure makes it very hard, and for anyone can change and delete information because we are blocked the data by using hashing algorithms. The hashing algorithms means encrypted data actually. What makes blockchain special is that it doesn't need to any one central authority actually to control it. Instead of it, many computers called nodes work together to verify and store the data. This makes blockchain is reliable and safe. This verification process is what makes blockchain so secure. Since no single node has complete control, it's nearly impossible for any individual group change or delete information without approval of this entire network. This setup actually creates a secure and trustworthy environment for storing sensitive data. We can easily trust it. So let's look at some application and use cases of blockchain. There are a lot of usage area of using blockchain. First is fintech. For example, blockchain helps make financial transaction faster and more secure. It's used for digital payments and cryptocurrencies, for example, Bitcoin and Ethereum. Second is government. Blockchain can improve public service by making records secure and transparent. For example, it can be used for voting actually and land registration. We can imagine all nodes as a maybe person, and let's think about there is a voting, and everyone can be sure the data cannot manipulate because no just one person or groups not store all of the data, and anyone cannot change the data, and I think it's very important. Next is real estate. Blockchain help track property ownership and simplifies buying and selling process, making them faster and more reliable. Then in the banking sector, blockchain reduces the fraud and increases the security of money transfer between banks or any individual person. And security is another key area. Blockchain secure and structured protects data from being tampered and with or hacked. In education, we can mention it. Blockchain can store and verify student records, and anyone can change it. And lastly, actually, gaming sector. Blockchain makes in-game assets and more secure and allows players to truly own their digital items. Maybe NFTs is like that. Actually, these are just a few examples of the how blockchain is transforming different industries, making them safer and more efficient. So I would like to mention about actually smart contracts, because the smart contracts are key component of the blockchain on the blockchain Web3 applications, Web3 services. In order to understand smart contracts, we need to understand the life cycle. Firstly, actually, a smart contract is a digital agreement written in code. We can think it just a code by stored on the blockchain. We say that anyone can change in the practical side. Anyone can change the data on the blockchain. So if we develop a smart contract, for example, we can say that if payment is received, then the product will be shipped actually. Today, we already actually create contracts with individual person or companies, but we cannot give a secure or reliable contract. We cannot create because we cannot agree, or someone maybe don't agree this contract. But if we develop smart contracts on the blockchain, anyone can change, and everyone can accept the contract. Firstly, actually, people or companies identify the agreement. As I said, they decide what they want from the contract and what the result should be. It depends on your requirement. Next, they set specific conditions. For example, as I said before, you can, if you send me money, I can send the car, for example. If payment is received, then the product will be shipped. These conditions are very important because the smart contract will automatically check if they are met and run it. After that, the code is written by some programming languages. For example, if we develop a smart contract, usually we are develop a smart contract on the Ethereum blockchain. We need to use the Solidity. This code actually this means the turning the agreement and conditions into computer code that the blockchain can understand, because the blockchain actually works on the computers. Blockchain consists of computers. When the conditions are met, the smart contract moves to the execution stage. The code runs automatically and record the result on the blockchain. And no one can claim I couldn't receive the car. I sent the money but I couldn't get the car. The information is stored on the blockchain. Finally, all network nodes update their records, and so everyone has the same version of the contract and its outcome. This transparency builds trust and ensures the contract does exactly what it's supposed to do. We can easily say that. So I think it's enough for the understand the main idea behind of the blockchain and node engine smart contracts. After, I would like to mention about how we can use it. Okay, it's very good. I can use it on the very application, but how we can use it, how we can connect the blockchain, how we can develop a decentralized application. On this stage, Huawei Cloud has a perfect service. This service name is Node Engine Service, Web3 Node Engine Service, as I mentioned before. Let's introduce Web3 Node Engine Service, or NES. Web3 Node Engine Service, developed by Huawei Cloud, is a platform for managing blockchain nodes. Node Engine Service helps developers and business by making it easier to create, manage, and scale blockchain nodes. This service is actually especially useful for building decentralized application. We gave a lot of example, and I will give also. As it provides all necessary tools and infrastructure. We don't need to worry about how we can manage the infrastructure of the blockchain. Node Engine Service makes it easier for us. Also, Node Engine Service gives developers a stable, efficient, and secure way to connect with popular blockchain networks. As I said before, Ethereum, Tron, and Polygon. With NES Node Engine Service, developers don't need to worry about setting up and managing their own nodes. Instead, they can focus on applications, building applications, while NES handles the backend node management. Because node management is very important, uh, you can think about a web application. Uh, on the best practice, we need to set a scaling up or load balancing, because when we send the request on the computer, uh, on the best practice, we need to make some configuration. Okay, we create a node on the blockchain such as Ethereum or Tron or Polygon, but on the other side, we need to also manage a lot of variable. So by using Node Engine Service, we just focus on developing application stage. In summary, actually, Node Engine Service makes it simple to interact blockchain networks, providing a reliable foundation for Web3 application. Then let's go over the key features of the Node Engine Service. First, actually, we have node management. NES actually allows developers to easily create and manage full nodes and staking nodes on major blockchain like Ethereum. This feature makes it simple to deploy and operate nodes without dealing with complex setups. And second, API integration. Okay, we create the nodes. Okay, but how can I integrate the blockchain? On the other hand, API integration, NES provides a secure and reliable APIs that let you access blockchain and data, perform transactions on the blockchain. This helps developers connect their applications to blockchain networks more efficiently. Next is high availability. NES ensures the 99% uptime for nodes operations. It offers quick recovery and fault detection. Yani, for example, if we have a node and if we build an application, decentralized application on the blockchain, the nodes should be available all of the time, because if the nodes shut down, our application also shut down. Which means that even if there is an issue, the service can quickly get back to normal operation. This orchestration provided by Node Engine Service. Finally, as I mentioned, scalability. NES can automatically scale resources to meet the demands of your application. You don't need to guess the capability or traffic. Scalability providing by Node Engine Service. This is very important, I think, when your project grows and needs more power and resource to keep running smoothly. These features make Node Engine Service a strong platform for building, managing, and scaling blockchain applications with scalability and security. Then let's look at how can do it. We understand actually how can we do it, but on the blockchain, this is very easy. Just 4 step. Just we need to understand the main idea before of the fourth step. First, step 1 is a create node. I will show you how can we create node on the Huawei Cloud Console. Start by choosing whether you need a dedicated or shared node. Configure its settings according to your needs and launch the node. These setups this step actually setups the foundation of your blockchain interaction. You can create a node on the blockchain, but we need to connect them. Then to make it, we need to create API key. Once your node is running on the, for example, Ethereum blockchain, we need to create a securely API key. So this key is essential for connecting your node and accessing its features, because the node provide us the information of the blockchain. We are using it, write and read of the information of the blockchain. After creating API key, we need to connect. We need to interact with the blockchain. We are using the API key to perform various tasks. You can execute transaction. You can send, for example, at, or you can also trigger a smart contract by using the API key, which simplifies the process of working with blockchain network. Then we should monitor and manage it. The usage the Node Engines console, service console, Nest console, to monitor your node's performance and make any necessary adjustments. This ensures your node is running smoothly and efficiently. Actually, following these steps make it easier for developers to work with blockchain technology and build reliable decentralized application. Let's look at application scenario. Web3 Node Engine service helps with the public blockchain interaction, especially crypto wallets. In the past, actually, decentralized platform developers, decentralized application platform developers, developer teams had to create and manage their own nodes without using any node management orchestration tools in order to give the users a good experience. But as more people started using these services, it became harder and keep everything running smoothly. Then we need to some useful tools in order to manage our nodes on the blockchain. So on this step, Huawei Cloud Node Engine service solves this problem by offering ease of use and high reliability, fast response, and related service. Let's try to explain each of them step by step. Ease of use, actually, simple and easy node management, and high reliability. Nodes stay online with almost no downtime, as I explained before. The nodes can be shut down, but the orchestration of the Node Engine service will automatically start it without any delay. And fast response, quick access to blockchain, because we should, if when we send a money to someone, we want to make it very fast. So fast response is very important, which is important for crypto wallets also. And related service, extra supports for decentralized application features. These benefits actually makes it easier for developers to connect with major blockchain like Ethereum, Tron, Polygon, helping their applications run better and faster. So I will make a demo on this session. Let's look at how we can do it. Firstly, as I said, I will make a demo on how to set up blockchain interaction using Node Engine service. Step one, we will select a preferred blockchain. Start by choosing the blockchain that you want to connect with. Options include popular frameworks like Ethereum, BNB Smart Chain, Polygons, and Tron. You can select anything, whether uh, either the mainnet for real transactions or testnet for development and testing. And step two, set the node type and specification. We will configure our nodes or node settings. Choose the node type, such as a full node for blockchain validation. Select the consensus client, but you need to pay some at. We will use just full node in our demonstration. We need to set the execution client, such as get. Finally, specify the resources for our node, like the number of CPU and memory size. These steps will help us to stop and customize our node for blockchain connectivity. Then, after we choose the configuration, we click the create button to complete the node creation process. This starts the deployment of your node on the chosen blockchain network. Then, on the step 4, once the node is created, we can monitor its status in real time. This helps us keep track of key metrics like peer count, block height, and network traffic, etc. In the step 5, we can check the node information. After we create node, we can check the configuration and information of the node, such as creation date, execution client version, and endpoint URL. We are using the endpoint URL in order to connect the node from our client. These steps actually will help us. Then let's move on to the final step, a final part of our demo on the blockchain interaction. After we create nodes on the blockchain, we are creating a node on the Ethereum blockchain network. After created it, we need to create an API key to enable secure interaction with our node. So retrieve the API key and endpoint detail. We will obtain the API. Also, we need to merge it with the endpoint of the node. This endpoint is very crucial for connecting your application to blockchain and performing actions like transaction and data queries. Then full node user guide. For more detailed information on using your full node, refer to the full node user guide provided by NES. There is a detailed documentation. This guide covers how to use the node for tasks such as the decentralized application and wallets and data analysis. So, which types of API we can use? You can see the API usage here. Some examples of API usage for interacting with blockchain data. First, we have querying block information. This JSON RPC request actually uses the get block. You can estimate, you can guess the main responsibility of the API. Get block by number. We can read the providing the block number in the parameters. We can retrieve detailed information about the specific blocks. This is very useful for checking data like transactions, transaction counts, and block size. Next is querying transaction information. This example on the slide shows a request using the get transaction by hash method. By passing a specific transaction hash, we can get detail about particular transaction, such as the sender, the receiver, and the transaction status. Lastly, we have sending Ether between users. The Ether sending users method allows for transferring Ether from one user to another. The parameters include details like the senders and receivers addresses, the amount to be transferred, gas limit, and gas price. This helps developers facilitate transaction directly on their decentralized application or wallet interface. These API examples actually demonstrate how to query and interact with blockchain and data efficient by using JSON RPS calls. We will make these steps step by step on this demonstration. Then I would like to mention the billing example. This is the this slides show you can show you for a dedicated Ethereum node using NES for 1 month. The bill includes 3 parts. Actually, one of them node fee for running the node continuously, and storage fee, an API calling fee. Actually, this presentation is like this. Thank you so much. I will also mention about the demo, a short demo. Then we can make a let's have a 5 or 10 minutes break, and let's meet again on the 10 minutes later. Thank you so much. Hello everyone again. On this section, we will make a short demo. So I will share my screen. I hope everything is okay. So actually today, I mentioned before how we can use the Node on for developing decentralized application, and I will show you also how we can use it, how we can make it on the demonstration. Firstly, in order to develop decentralized application by using Node Engine service, you have to register with Huawei Cloud. This is the first prerequirements. So if you registered on the Huawei Cloud, you can find the Node Engine service by writing here Node Engine service here, and also you can find all service of the Huawei Cloud, like AI on the AI or for example containers such as Kubernetes environment here. And when you open the Node Engine service, you can see the main page, main dashboard here. On this demonstration, we will create dedicated Node Engine node. So I will click the dedicated. And you can see the dashboard here. I mentioned before this you can monitor your status of your nodes here, service overview, etc. Then, in order to create a node, I click the network management, and I just click the join public blockchain here. After I clicked join the public blockchain, here you can see the available blockchain networks here. I will create a node on the Ethereum, and I will choose the mainnet here. I will choose my enterprise project. Then the node type will be full node, as I said. You can also create a staking node in order to validate and the information, the transaction of the blockchain. But I will create full node. Then you can select the specification here like this. I will choose the node has a 8 CPU and RAM. Then I'm clicking to create, and I have read and agree and click submit, and you can see the information about your node here before submit. After I click the create node, you can see the status and some detailed information about your node. There is a node ID status, there is a node type here, and specifications like this. Then, as I explained on the theoretical side, after I creating a node on the blockchain, I need to connect it. I need to connect it because I need to get some information from the blockchain. I need to send information. I need to trigger some smart contracts, etc. So here I have a node on the Ethereum blockchain now. Then I will create an API key. Here you can see API keys here listed, and I will create a new API key. After I create API key, you should fill the information here. Here you can see the target nodes. We already created a nodes on the blockchain. Now I will choose my node here. Then I will choose whitelist. Then I will click OK. After I create API key, content type not supported. Let's try again. After I click OK, the API key created and credential zip file is downloaded. I have a critical information on it about API key. You can see the credential file here on the downloads. I will open it. I will unzip it. The credential files is a CSV file, comma separated values file. On this CSV file, you have secret information such as ID and credentials. This information is very important because we should merge it with the Node Engine service in order to connect blockchain. So after I open the credential file, I see the credential key here, and I will copy it. Then I should merge with the endpoint of the node, my node. Here you can see how can I see the endpoint of the nodes. You can see the details information of the nodes. Here you can see the HTTP endpoint here. I will copy it and I will open the Postman. I will choose the post method. I will paste my endpoint, HTTP endpoint of the nodes which deployed on the Ethereum blockchain. Then I need to combine it, as I said. I will paste my endpoint on the Postman. Then I have combined it with the credentials, with my credential. Also, I will paste it. I will add a slash and I will paste my credential key. Sorry. Yes, I will copy it. Okay, I determined the API. So I need to send somebody. Actually, we saw the examples of the JSON RPC request. We can also copy or write. I can copy on the presentation. API usage. For example, I want to read the information of the blog. I will use the get blog number method, and I will give some parameters, some blog parameters, and let's see the answers. I just clicked sending request now. SSL error we gave. Let's check it. Maybe we couldn't combine all or HTTP endpoint and credentials. Let's check it. Or we can also write wrong request. Let's write again JSON RPC and EK0 and ID 1. Method will be Ethereum block number. Block number, and I will give some parameters like this. Sorry, yes. Let's send again. Oh, sorry, because I have a VPN. I need to close the VPN. It's don't allow me to send API request.